Hello, I'm Anna Mackay and today we're looking at using trigonometric functions, so two real-world applications. Our first example here, we're looking at the height of the tide above mean sea level on January the 24th at Cape Town, and it's modelled by this equation where t is the number of hours after midnight, and we have to graph that for t between 0 and 24, so for 24 hours. So grab your graphics calculator out for this video. And the equation that we're typing in is here. We've got 3 sine bracket pi t, but instead of t we're using x over 6. And now let's think about our view window. Our x is our domain, and that's the hours after midnight. So we're interested from 0 to 24. I like to go one more than that, just so you've got a little bit of extra view. And your y, now that's the range. Now, for a sine function, the range is, you look at the amplitude, and usually it's an amplitude of 1, so from 1 to -1. But which number in that sine function will affect the amplitude? It's the a value, if you like, so it's the 3 in this case, the 3 that's the coefficient of sine. So that means the amplitude is 3. So we're going to go up to 3, which is 3 meters, and down to -3. For my view window, I like to have one either side. So I'm going from -4 to 4 for my view window with a scale of 1. Let's see if that's right. Yes, it fits in our view window. So there's our graph for that. Next part. Now I'm just going to move this slightly out of the way so we can go to the next slide. And we're asked, when is the high tide and what is the maximum height? So when, that refers to the t. When is the high tide? So we're after the maximum. So we're going to g-solve this, g-solve the maximum, and we've got x is equal to 3. And because it's hours after midnight, that makes it 3 a.m. And what is the maximum height? It's 3 meters. However, there's more than one maximum high tide, so you would arrow across to the next one, which is x is equal to 15. So that's 15 hours after midnight. So I guess subtract 12 for half of the day, and now you're at 3 p.m. Just check that. Our answer would be the high tide is at 3 a.m. and 3 p.m. and the maximum height is 3 meters above the mean, as seen at points A and B, if you needed to graph that. Part C, what is the height of the tide at 2 p.m? So at 2 p.m, that's your t's time. What value of t should we put in now for 2 p.m? Don't say 2, 2 p.m. So it's how many hours after midnight? That's 14. You can use now hang on, if we're solving for a y calc, you could use that function. I quite like to use trace, and then you type your number 2 in, x is 2, and you look at your y value, 2.598, so 2.6, that is our height. Let's see what we've got there. At 2 p.m, the tide is 2.6 meters above the mean. And the other way to solve that is algebraically. You go back to your function, and where you see a t, you substitute in, well, not 2, but 14, and just calculate that out. Right, next. And part D, a ship can cross the harbour provided the tide is at least 2 meters above mean sea level. When is crossing possible on January the 24th? Now, a technique that I like to do is, as often as possible, create a visual. See what this could look like. So when is it above 2 meters? So is 2 meters an x value or a y value? It's a y value. So that means we can graph y is equal to 2. And let's see what that looks like. There you are. So now you've got an idea that the ship can cross the harbour when it's the water line is above the red line, if you like. And so there's 2 windows when that can happen. You can see my mouse cursor here. It's between these points. And so when is it possible? So we need to find the intersection points of these 2 graphs. So intersection, the first one here is x is equal to 1.39. The next one, and so these are, when is it possible? These will be your time. So when time is 1.39, 4.6, 13.39 and 16.6. and these are in hours after midnight. However, we don't write 1.39 hours. So it's 0.39 of an hour, That of in mathematics often means multiply. So here you would go into your run menu and you would do what is 0.39 of, multiply an hour, 60 minutes, and you get 23. So we're talking 1 hour and 23 minutes. So 1:23 a.m. would be the first time that this ship could go into the harbour. Here's an answer with that all written out neatly. So down the bottom here you can see the 1.39, the 4.61, the t values, and then there's that 1 hour and 23 minutes. So that's how you turn the decimal into the time equivalent. Right. Our second example. The average daily temperature in Buenos Aires during the year is given by this function of t, and it's a cos function, where t is the time in months, with January being 1 month, February being 2, etc., up to 12. And we're asked to sketch t. Right, so let's go into our graph and graph that. So I just want to delete the previous ones that I had, and we've got 4 cos bracket as a fraction, pi times by t, or x in this case, divided by 6, close bracket, plus 20. Now we're going to have to think about our view window. So for our x values, our time, it's given us for 0 to 12. So we can go 0 to 12, or you might go 0 to 13, whichever works for you. Now our y values. Y is the range. So this is where your knowledge of the sine cos functions comes into play. Usually our amplitude is 1, so we would go from 1 to -1. However, have a look at that 4 out the front of the cos. That means the amplitude is now 4, so we would need to go from 4 to -4. However, if you were to do that, oh, it happens to be on my screen, let's graph that, see what happens. We can't see anything. So something else has gone wrong here. Have a think about that extra plus 20 on the end. If you think back to your knowledge of linear equations, that mx plus c, that plus c is the y-intercept. And the same applies here for trig functions, that number, that 20, will be your y-intercept. It also implies it's had a vertical shift up to 20. So 20 is now our principal axis, if you like, and our max and mins will alternate around that 20. So we've decided that our amplitude is 4. So if we're at 20, we can go up 4 and down 4. So from 20, we could go to 24 down to 16. And so for our view window, my suggestion is 15 to 25. And let's see if that works. So 15 to 25, graph again. And there we have it, much better. I'm sure there's a zoom fit option that you could go into to start with to get an idea. But this, I guess you need to have a knowledge of these trig functions to know what's reasonable and understand what that 20 and what that 4 mean. Now let's get on with solving the questions. If we're asked to find the average daily temperature in the city during June, what might that mean? An average? So the average of this graph, I guess it's, add them all up and divide by how many's there, that's an average. I guess it's sort of the distance in that sense between the most extreme and the least extreme. And that is the principal axis. So the average daily temperature, we've talked about what that would be 20. And if you want to see it visually, graph 20. Y is equal to 20. Does that look like about halfway between the top and the bottom? Yes, it does. So your answer, find the average daily temperature in the city during June. 16 I've got. During June, right, my apologies. If we were after the average daily temperature for the whole year, that's what we'd be after. But in June, it's how many months after January, which is 6. So you would shift trace of 6 and we get a 16. Again, it's hard to see that with the cursor. So you could adjust your view window if you wanted. I'll just demonstrate that to you so that it might be easier to see. If I now trace 6 months, 16. It's getting a bit easier to see there. You can adjust your view window if you need. And then part C, in which months is the average temperature 22 degrees? So now temperature is 22. Is that our X or Y value? That's our Y value. My advice, graph 22. What if it happens more than once? It does. In which months is it 22? Now just remember my view window there, I've extended, so I should come back to the domain of 12 for 12 months. Now there's 2 intersection points. So let's find those. The first one is that X is equal to 2, which is the second month, February. And the next X value is 10, and the 10th month is October. So there are answers there. Okay, just some extra tips here when you come to do the questions of 7F. I did notice that they might not quite be what you expect. For part B, I think it's referring to a minimum as opposed to a maximum, and part D, I think it should say under 10,000. Okay, well, that's the end of this series actually on the applying trigonometry. And if you've been wondering what all of these 100s have been about, well, this is my 100th video recorded for my YouTube channel. So happy birthday to me. Thanks for joining me, and I hope to see you for the next 100. Bye.